Imagine turning ancient fossil shells into the future of solar energy. Intrigued? Keep watching to discover how a German-Algerian team is revolutionizing silicon production. A German-Algerian research team has been investigating ways to produce silicon from diatomite, a fossil material containing amorphous silicon dioxide. The researchers said that, for potential solar cell applications, it will be crucial to extract silicon with a low level of impurities. Diatomaceous earth, also known as diatomite, has been used as a material for liquid filters since the 19th century. It is also used in the manufacture of thermal insulation materials, grinding and polishing agents, cleaning agents and insect repellents. The use of this material may be extended to solar cell manufacturing, according to a group of researchers from the Hauck University of Applied Sciences and Arts Hildesheim/Holzminden/Göttingen in Germany and the Algerian University of Oran. The sediment consists largely of the shells of fossil diatoms containing amorphous silicon dioxide. Diatomite mining in northern Germany began around 1840 and was stopped in 1994. Until the beginning of the 20th century, the deposits covered almost all global demand, and later the material was also mined in numerous other countries. Currently, there are large deposits in the USA, Denmark, Turkey, and China. The scientists explain that the detection of impurities in diatomite will be a critical issue during the silicon extraction process, noting that impurities can significantly impact the performance of silicon solar cells. To solve this issue and assess the quality of diatomite, they applied a sensitivity-improved calibration-free laser-induced breakdown spectroscopy (LIBS) measurement methodology. The academics also assessed the morphology and properties of the diatomite surface using energy-dispersive X-ray spectroscopy and scanning electron microscopy analysis. Their findings are available in the study Quantification of Impurities in Diatomite via Sensitivity-Improved Calibration-Free Laser-Induced Breakdown Spectroscopy, published in the Journal of Analytical Atomic Spectrometry. This research contributes to process optimization in the fabrication of electronic-grade silicon from diatomite for photovoltaic technology and other applications, they concluded.